Propane is an alkane with the formula C3H8. And I've drawn out the displayed formula just here so we can see the 3 carbon atoms and the 8 hydrogen atoms, all joined together by lines or single covalent bonds or shared pairs of electrons. A. What is the general formula for alkanes? So for alkanes, each carbon atom has 2 hydrogen atoms, one above it and one below it. Plus, there are 2 hydrogen atoms at each end of the chain. So that means that our general formula, for every carbon atom, there's 2 hydrogen atoms, one above and one below, plus 2 hydrogens, one at each end of the chain. So we're looking for Cn, H2n plus 2. B. What type of bonding is found in propane molecules? And as soon as we see that word molecules, we know that we're talking about covalent bonds, shared pairs of electrons, which you will recognize as being drawn as single lines on diagrams. So we're looking for covalent bonds as our answer. And then C, propane burns in a good supply of oxygen to form carbon dioxide and water. So we've got complete combustion taking place. Balance the equation below to show the complete combustion of propane. So what we're going to need to do is to make sure we've got the same number of each type of atom on the left and on the right-hand side of the equation. So let's list our elements. We've got carbon, hydrogen, and oxygen. And if we do in the same order, the product side, carbon, hydrogen, and oxygen. Okay, let's look and see how many atoms we have of carbon at the start. So there's 3 carbons on the left, and there's also 3 carbons on the right. So that's super, they balance straight away. On the left-hand side, the hydrogens, we have got them as 8, they're just in one place. So it's 8 hydrogens on the left-hand side, and on the right-hand side, there are 2 at the moment, so they don't balance yet. Oxygens on the left-hand side, we have got 2. And on the right-hand side, the product side, we can see oxygen is in 2 places. So it's in carbon dioxide and it's also in the water. So in the carbon dioxide, we've got 3 times 2. So we've got 6 oxygens there. Plus we've got 1 in the water. So that gives us a total of 7. Now we're going to need to make sure we've got the same number of each type of atom on both sides. So we can see we've got 8 hydrogens on the left-hand side, only 2 hydrogens on the right-hand side. So if I place a 4 in front of the water, that will affect the hydrogen and the oxygen atoms. So let's recalculate what we've got. So 4 times 2, there's now 8 hydrogens. So the hydrogens balance, which is excellent. And let's have a look at the oxygens. So we've still got 6 in the carbon dioxide, plus 4 in the water. That now makes 10 oxygens on the products or right-hand side. Now, the oxygens come in pairs. Oxygen molecules are O2, and we need to have 10. So we're going to need to place a 5 in front of the O2. And 5 times 2 is 10. So that means there's 10 oxygens on both sides. So the equation balances. Now we've got the same number of carbon, hydrogen, and oxygen atoms on both sides of the equation.